All right, we're going to look at some data here. Let me flip over to my spreadsheet and we're going to create this data. But let me talk about this data in its form. And so what we're looking at here is we have 62% of people surveyed of cancer survivors. Oops, let me exit out of that. Remove that. There we go. 62% of cancer survivors are over 65. So if we take 6 cancer survivors and we randomly pick one of them and we ask them, are you over 65? Well, the chance of them saying yes the percentage chance of them saying yes is 0.62. This keeps popping up. Switched over to my Windows machine because Excel is better on my Windows machine. And it has a slightly different, every time I go to click on something, draw a circle, 62. So point, see, I'm trying to draw a dot and it draws a circle. The Windows ink. There we go. And so our probability of x is going to be NCX times P to the x Q to the n minus x. And so in this case, we have 6 trials, and we have to work our way through all the x values with 0.62. To the x. I must have changed colors. And then 1 minus 0.62 to the n minus x. Put a minus in there. And minus x. And so 1 to the n minus x. And so, whoops, our n is 6 here. And we choose our individual x values. Now again, we can use the formula to create this, but I'm going to create it in Excel, and then we're going to let Excel graph it for us. So I'll come over to a workbook here. And we're going to make room for our data. So our x values, since there are 6 trials, we can have 0 successes all the way up to 6 successes. And the probability of each success is the binomial distribution. And then in our x, which in this case I'm leaving as cell B2. And then our number of trials, which is 6. Our probability of success, which is 0.62. And then if it's cumulative, which in this case is going to be false. And so this shows me the probability of success, and if I drag this down, it gives me the probability of success based off of each number of successes. Well, I can make a pseudo-histogram from this. If I select both these columns and I go to Insert, and then I'm going to go to Recommended Charts, and I'm just going to do a cluster column for right now. And the cluster column shows the basic distribution here. Right? It's skew left a little bit, and it's spread like this. And we'll make regular histograms out when these go through, but we get an idea of what this probability distribution looks like. And then there's just a couple more things I want to show, if I can get the Blackboard to agree with me here, which is some other data we can get from this. And so this distribution has a shape. That shape means that it has values in it, a measurement, a spacing, it has a middle. And so for binomial distributions, so in binomial distributions, I'm just going to abbreviate it, binomial dis. The mean is equal to the number of trials times the probability of success. The variance is equal to the number of trials times the probability of success times the probability of failure, which means the standard deviation is the square root of this. And so there's an easy way of finding the mean and the variance. And so if we come back to our Excel spreadsheet here, I can give a calculation for the mean, where the mean was equal, what was n? We had 6 trials, and we had a probability of success of 0.62. And so this has a mean of 3.72. It has a variance, which is equal to n, which was 6, times 0.62. Now Q is 1 minus P, so I'm just going to put 1 minus 0.62. Oops, did I have a typo? What did I do in there? 6. We found a typo in your formula. What did I typo? We corrected it before I could see it. So it's 6 times 0.62, 1 minus 0.62. And the standard deviation is the square root, SQRT, of that previous cell, which was C19. And there I have my measurements. And so now I can talk about this distribution just like we did with descriptive statistics.